In this lesson, you'll be learning how to partition a segment. We'll use a graphical and a numerical approach. Here's our first example. A student graphed segment PQ on a coordinate plane as shown. The student will plot point S on PQ such that the length of QS is twice the length of SP. Determine the coordinates of point S. So what we want to take is the information regarding the length of QS compared to SP. We find out that it's twice the length. So we can write a ratio, QS to SP equals 2 to 1. Now those are parts, and 2 parts plus 1 part equals 3 parts. So in essence, we're going to divide this line segment into 3 equal parts. And it's a good idea to determine the vertical distance between the endpoints, and that's going to be 12. And the horizontal distance between the endpoints is going to be 9. And now that we've done that, we can figure out, starting at point Q, how far down should I go by finding 2/3 of that vertical distance of 12, and that's 8 units down. And how far over do we go? 2/3 of the horizontal distance of 9 is 6. So starting at point Q, we're going to go down 8 units and over 6 units, and our point S is going to have coordinates -1, -2. Now just to show that this all makes sense, remember originally we knew that we were going to divide the segment into 3 equal parts. And so there, with that point shown on the segment, we can see the 3 equal parts, and we can see that the length of QS is twice the length of SP. So we used mostly a graphical approach there, but we could also think of this same problem more numerically. We still want to look at the given information about the ratio of QS to SP as 2 to 1. We still want to think about 2 parts plus 1 part equals 3 parts. And we do want to at least visualize the horizontal distance and the vertical distance. Now, you can see that from 5, which is the x-coordinate of point Q, to -4, which is the x-coordinate of point P, that's 9 units over. And looking at the span of the vertical distance between the points, 6 plus 6 is 12. So we're just going to jump right into an x and a y coordinate. And we want to start at the x-coordinate of point Q, which is 5. And since we know we're going to go to the left, we're going to do 5 minus 2/3 of that horizontal distance of 9 units. So 5 minus 2/3 of 9. Now 2/3 of 9, 1/3 of 9 is 3, so 2/3 of 9 is 6. So 5 minus 6. The x-coordinate of point S is going to be -1. Now we can go on to the y-coordinate, and we start with the y-coordinate of point Q. It's 6, and we're going to subtract 2/3 of that vertical span of 12 units. So 6 minus, now think about 2/3 of 12. 1/3 of 12 is 4. 2/3 of 12 would be 8. 6 minus 8 giving you -2. And -1, -2 are the coordinates of point S. Let's take a look at another example. Line segment FG is graphed on this coordinate plane. And this time, we want you to pause the video and consider, where would you plot point E along segment FG such that the length of FE is 3 times the length of EG? Determine the coordinates of point E. Go ahead and try this one on your own, then we can compare your approach with what we have ready. So we're going to remember that the given ratio is important. FE to EG is going to be 3 to 1. 3 parts plus 1 part equals 4 parts. So in essence, we want to divide this line segment into 4 equal parts. To help us do that, we're going to determine the rise of 8 and the run of 8. So 8 is the vertical span, 8 is the horizontal span. We want to find point E, we want to think of 3/4 of 8. And we're going to go up 6 units from point F. And then 3/4 of that horizontal distance of 8 equals 6 will also go over 6 units. So starting at point F, we're going to go up 6 and then over 6, and that's where we land. Point E has coordinates 3, 2. And our last example, there is no coordinate plane. Consider line segment ST, which is graphed on a coordinate plane not shown. The coordinates of endpoint S are -2, -6, and the coordinates of point T are 18, 9. Point Q lies on segment ST such that the ratio of SQ to QT is 2:3. Determine the coordinates of point Q. So there is no coordinate plane, but there's no harm in sketching a quick graph and just identifying where point S would be over there in quadrant 3 and point T would be over in quadrant 1. Looking at the information about the ratio, SQ to Q2 equals 2:3, that means 2 parts plus 3 parts. There will be 5 parts that we would divide this segment into. Visualizing the horizontal distance between the 2 points, looking at those x coordinates. The horizontal distance between the points would be 20, and the vertical distance between those points, 6 plus 9, would be 15. So now jumping into the numerical approach, we're going to look at our coordinates for x and y of the point that we've been asked to determine the coordinates of. And starting at point S, the x coordinate is -2, and we're going to add, because we're going to the right, 2/5 of 20. 1/5 of 20 is 4, so 2/5 of 20 is 8. -2 plus 8 is 6. The x coordinate of point Q will be 6. Now let's determine the y coordinate of point Q. Starting with the y coordinate of point S, which is -6, I'm going up, so it's going to be -6 plus 2/5 of the vertical span between the two endpoints. 1/5 of 15 is 3, 2/5 of 15 would be 6, -6 plus 6 is 0. So we believe the coordinates of point Q are 6, 0. Now let's just sketch a quick line segment between S and T as the endpoints. Let's locate 6, 0, and does it seem to you that that placement matches the detail that the ratio of SQ to QT is 2:3? Looks good.